Hey guys, Mr. Gran here, 13.2 angles of rotation. In this lesson, or in this video, we will be finding trig ratios of angles of rotation. So what we are going to do, what we're talking about here is angles of rotation that end at an xy coordinate. So we've got some steps that we can use to solve these types of problems. So first we're going to plot the point on a graph. So you're given an xy coordinate, so we're going to plot it on the graph. Then we're going to connect that point to the origin and draw a vertical line to the x-axis to make a right triangle. So we're putting a right triangle on the graph that has the one angle at the center of the graph, at the origin. The angle at the origin is where we're going to put our theta. We're going to have to use the Pythagorean theorem to find the hypotenuse. And then we're going to label our sides and then find our 6 trig ratios. So pause the video if you want to take those steps down and resume when you're ready. All right, so this is a typical problem. We've got a point, -2, 4 on the terminal side of theta is what that should say, not the question mark. So that should be a theta. And we want to know what are the 6 trig ratios for theta. So the first thing I'm going to do is plot the point -2, +4 right there. Then I'm going to connect that point back to the origin. And I'm going to turn this into a right triangle by making a vertical line and connecting back to the origin. We'll put theta right here. That's the angle we're talking about. Now on this triangle, I have a base that has a length of -2. So we've got a triangle with a negative side to it, and that's fine for this. I've got the height of 4, and I need to use the Pythagorean theorem to figure out what my hypotenuse is. I'll make a little 90-degree angle symbol right there. All right, so a squared plus b squared equals c squared. So we're going to do -2 squared plus 4 squared equals c squared. All right, now notice I have -2 in parentheses. If you're using a calculator, if you square -2 and you don't have it in parentheses, it's going to give you a -4, but it should be a +4. All right, and then 4 squared is 16 equals c squared. That means that 20 equals c squared. And that means if I take the square root of both sides, I get that c is equal to the square root of 20. Now, this is not in simplest radical form yet. To get it in simplest radical form, I can simplify this radical. This factors to 4 and 5. 4 factors to 2 and 2. So that means that the square root of 20 is equal to 2 times the square root of 5. So my hypotenuse is 2 root 5. Okay, so now it's basically SOHCAHTOA at this point. I've got my opposite, I've got my adjacent, I've got my hypotenuse. So sine is going to be equal to opposite over hypotenuse. Oops. That is 4 over 2 root 5. Now this can reduce and then simplify. So the 4 over 2 reduces to a 2 over 1. So this becomes 2 over root 5. And then now we could leave this answer just like it is. If we want to rationalize the denominator, I would multiply the top and bottom by the square root of 5, and that would give me 2 root 5 over 5. All right, cosine, same idea. -2 over 2 root 5, my adjacent over my hypotenuse. And again, the 2 over 2 cancels, so that makes it a -1 over root 5. And I could use this as my answer, but if I wanted to fully simplify it and rationalize it, I would multiply the top and bottom by root 5, and that would equal -root 5 over 5. And then tangent, that one's a little bit easier, no rationalization. Opposite over adjacent is 4 over -2, which is going to reduce to just -2. Okay, so that's my sine, cosine, and tangent. And I'm kind of running out of room here. So I'll put my secant, cosecant, and cotangent over up at the top. So cosecant, that goes with sine. And I'm just going to take this version that my pointer is on right now, and I'm going to flip that one. Because that way, there's not a fraction that's going to need to reduce, and I don't have a square root in the denominator, so it's not technically in simplest radical form. If I just take this and flip it, it's already in simplest radical form. Root 5 over 2. If I would have taken this version of the answer and flipped it, well, then I've got a square root on the bottom again that I need to get rid of to get its simplest radical form. If I would have flipped this, then I got to reduce the 2 and the 4 again, so it's easiest if I just take this one and flip it. All right, then secant, that goes with cosine. And so again, I'm going to take this version and flip it. And so that's going to make it negative root 5 over 1, which is just negative root 5. And then cotangent, that I'm just going to take the reciprocal of negative 2, which is negative 1 over 2. All right, here's one more example. So if you want to try it on your own and then unpause the video when you're ready. Again, terminal side of theta, and we want the 6 trig functions for theta. All right, so 2, negative 3 is right here. We'll connect that to the origin and then make this into a right triangle where this side is 2, the vertical side is negative 3. And now we want to use Pythagorean theorem. 2 squared plus negative 3 squared equals c squared. So that's 4 plus 9 equals c squared. That means that 13 equals c squared, which means that c is equal to the square root of 13 for our hypotenuse. And that one doesn't reduce, so we'll just leave it like that. All right, theta is in this corner. That means that negative 3 is the opposite. That means that 2 is the adjacent and root 13 is the hypotenuse. All right, so for our trig ratios, sine theta is opposite over hypotenuse. And again, this version of the answer is okay, but the rationalized version, the kind that you would see on an answer key typically, or as a multiple choice option, would be the rationalized version where it doesn't have a square root in the denominator. Then cosine, that is going to be similar, 2 over root 13, and again we can rationalize that. Right, so this is acceptable, but you might want to know that this is a thing. And then tangent is going to be opposite over adjacent. All right, then our remaining trig ratios, cosecant, that goes with sine. So we'll just take this one and flip it and make it negative root 13 over 3. Secant goes with cosine, so we'll take this one and flip it and make it root 13 over 2. And then cotangent, that goes with tangent, that will become negative 2/3.